sustainable and green energy technology in India. I also welcome to Shabnam Bassi Madam, who she is an expert on green technology. Good morning, Madam.
Good morning, sir.
Now, before start a session, now I would like to introduce the session expert, Madam Shabnam Bassi. She is Associate Director of GRIHA Council at the Energy and Resource Institute, TERI, and Secretary with GRIHA Council, which administrates a green rating for integrated habitat assessment. Prior to join the TERI, she has worked with the United Nations Development Program for nearly 5 years as an assistant project manager. She has been engaged to implement strategy to overcome barriers related to energy efficiency in building sector in the country by coordinating the central, state, and municipal bodies to facilitate the ECBC integration, development of framework to strengthen enforcement of ECBC implementation and compliance. She has worked with the Bureau of Energy Efficiency for 5 years. She was associated with the scheme related to promotion and implementation of energy efficiency in commercial building through the adoption of energy conservation building code in the built environment. She has worked in a close cooperation with various international agencies, expert in developing programs related to enhance of government policy for promoting energy efficiency in buildings. She was the lead person for spending of the development in the Indian construction sector, particularly those related with the building energy, green building. A part of this, she has been in the Indian PMU on the development of template, the public building in collaboration with state governments. Welcome, Madam.
Good morning, everyone, and thank you for inviting us to today's session. And I'll be very happy to address all of you. Thank you so much. Okay. Before I begin, I would like to inform you that I would like to keep this session very, very interactive. So I don't know how are we going to do that, but definitely I would like you all to please be very active on your chat boxes and ask as many questions as you can, because I understand that this is a topic which is probably you are doing it for the first time. And I am there to, walk you through this topic, and we will discuss a lot of things. And I'm sure with the experience that, I have, and with what you are going to do today, we are going to do something very new. So let me begin my presentation, and let me share the screen first. Ronak ji, do I have the sharing rights?
Yes.
Okay. So, are you able to see my screen?
No, Madam.
Let's wait for a minute. Probably takes time. Are you able to see my screen now?
No, Madam.
Okay.
First, you go to your presentation, and after you go to present now.
I have done that present now. Somehow. Is it visible now?
Yes, madam.
Okay. So, a very good morning once again to all of you. And let me put this on the presentation mode. Okay. So, a very good morning. I'm Shabnam Bassi. I'm Secretary and Associate Director with the GRIHA Council. And today I am going to talk about green buildings, and definitely, there is a lot that cover today. I have got roughly 6 sections to cover, and as you can see that we are looking at a time frame of 1.5 hours. So please feel free to ask or interject questions wherever you feel that you need some more assistance. So just to give you a background of who we are. So GRIHA, you will hear this name a lot today. So GRIHA Council is an independent platform. It is a green rating body. So it's an acronym for Green Ratings for Integrated Habitat Assessment. This is a rating body, and we rate projects, commercial buildings, residential projects, all kind of commercial projects, and definitely, we are talking about areas like renewable energy. We will talk about sustainable sites, sustainable water practices, and all that. So GRIHA is an independent council that was created way back in 2005-6, and it was a joint venture of Ministry of New and Renewable Energy, Government of India, along with TERI. So what was happening in 2004 and 5 is that there were a lot of glass buildings that were coming up, and the green ratings. I don't know if you all have heard about it, but there are a lot of other green ratings that are prevalent all over the world, like the LEED, IGBC, and they were, they're US based rating systems. So what they did was that when they came in India, they just did minor changes in the rating, and they ensured that the rating was dovetailed to suit our local climatic conditions. But it did not 100% capture the local essence, the way we construct buildings, the way we use buildings. So there was a big disconnect as to what our Indian ethos are. So there was a need to have a rating system that was an Indian context. So with keeping that in mind, the Ministry of New and Renewable and TERI, they came together. They created this rating, and there were a lot of local expertise that was involved in creating this rating. So this is how the creation has happened. Dr. Raj Mathur is the president of the GRIHA Council, and as you all may have known him, that he's a global person, and he is a think tank and to the co-chair of Energy Transition Commission. He's a main he's champion in climate change negotiations, which happen for all the climate change initiatives. So this is the chronology of the things that we have done till now. We did a couple of audits in the year 2000, and in the year 2007, it was felt that we should have a rating that is in very Indian context. That is how we were created. And as we kept going, there were a lot of organizations that started recognizing GRIHA. And by the time we have reached now, we have been adopted by a lot of state governments. And on the international platforms also, GRIHA has been recognized as India's own rating system. And in order to meet the international commitments that we have made to the UNFCCC, GRIHA is going to be used as a tool to measure emissions from buildings. So just to ask you a few questions, can you, just write on the chat boxes, where do you find, these kind of buildings, or, where do you think, which state will have these kind of buildings? So, I am expecting questions, or, I'm asking you because, then we can have, yes, it is Rajasthan, places from where, we see a lot of heat comes in, and these structures help us keep the buildings cool. So definitely, somebody has answered it right. It is from Rajasthan. Where do you think this building comes from? Okay, let me see the chats. Okay, Kerala, yes, there are people who are answering. Yes, these are the buildings that come from Kerala because they are humid places, rainfalls are high. So the kind of roofs that you see here are very typical of buildings in these places. And by the way, these buildings are from Surat. I think this is Hawa Mahal. Yes, this is Rajasthan. Yes. So in the examples that I've shown you till now, you may have observed that, we are making very, very state specific, the way the climate of that place is. It is responsive to that kind of climate. But now let us see if you are able to guess from where we are now. Any guesses? Where are these buildings from? Uttar Pradesh, no. Okay. Any more guesses? Dubai, okay. No screen, sorry. Actually, I was reading the answers parallelly, so let me put it on this. Yes, are you able to see both the screens? Because I have to read my answers parallelly. Okay. Just to take this conversation ahead, so the building on the left that you see is typically a building from the US, and the building that you see on your right is a DLF project which is in Gurgaon. Yes, somebody's answered it. Mr. Nishant has answered it. So yes, as you see that, this session is basically talking about these kind of issues in the country, that the buildings that we are constructing today are not in the context of what the climate is, what are the requirements of that particular place, but we are just blindly copying and aping from the West. So there is no difference between how the building has been constructed in US and how we are trying to construct it, and are we going to make any changes. As you can see clearly that we are just blindly copying it. So most of the buildings that you see on this page, are all glass buildings. So they are from different parts of the country, but neither are they climate responsive, nor in any context, or there are no integration of solar passive strategies. Nothing has been incorporated. So there was a big wave, in the year 2007, where there a lot of IT companies were coming in. So they were just blindly copying buildings from the West. And we all know that, if you look around, even in your areas, you will find that they're all, you would have seen a similar building somewhere around your vicinity. They're all glass buildings, and, we are just blindly copying, not understanding if glass is important, or if it is really required for that particular project, but we are more worried about the aesthetics of the building, how the building looks, and only about how a building, what is the demand for these kind of buildings. So the buildings have been sold only on aesthetics. We all know that the city landscape is changing. It's a very beautiful picture which shows that there are buildings, as you see in the front, they were made probably way back, and we had a lot of spread, and there were a lot of green covers, and, there were some buildings and were spread properly. But now that buildings that you see behind, they are all skyscrapers. The demand for housing has increased, the demand for building commercial spaces has increased. So our cities are changing, the way we are designing it is changing. So we have to take care of these things, that we also have to meet the growing demands of the country. So we don't say that, a good design is typically, it's not about aesthetics. Good design not only talks about aesthetics, but it should be climate responsive. It should cater to the to the climate of that particular place. It should have very good living environment and should have the cultural heritage of that place. I think then those buildings become extremely, a sight to watch, when we have these kind of structures. Just to give you a few statistics, the urban population is growing very rapidly. A lot of urbanization is happening. A lot of people want to come to urban spaces. So where are we right now? We are at 1.2 billion people, and we are going to reach to 1.4 billion people in the cities by 2025. So which means by 2030, nearly 40% of India's populations would be living out of the urban spaces. So we need to know where are these spaces and how are we constructing them. We need more cities, more people, and we need more buildings. So when we talk about a conventional building, that you would have seen that building and construction works have the largest single contributor in the global resources. Now this word resources is very, very important. We know that when we construct a building, or any building or any new project comes up, we are consuming land, we are using water, a lot of raw materials go into constructing building, and nearly 40 to 60% of it goes into energy is being used. When we talk about when the building is constructed, there are a lot of water effluents that have to be that go as waste. We have solid waste that gets generated, and a lot of emissions due to energy consumptions are also generated. So these are how we have been constructing buildings. This is how the glass buildings have an impact on how the buildings are running. Buildings, environmentally friendly design is no more a choice. We all know that in the coming times, we will not have a lot of resources to look up to. We will have to be sustainable, self-sustainable, and we'll have to see how we are able to keep to the future demands. What is a green building? Why should one go and opt for a green building? So to give you the basic definition of a green building will have minimal impact on the site. We will talk in detail about what does it mean. It improves the microclimate. They are energy efficient. They use minimum energy. They maximize the use of renewable energy. We talk about solar, wind, etc. The savings are, in terms of energy, are in the range of 40 to 50%. They have minimal impact on the people that are living out of that building. We will talk about the socioeconomic strategies. The water consumption, in a green building, it reduces by 40%. We all know that water is going to become a very big challenge in the coming years. So we have to do something about it. So GRIHA talks about how we are going to save water in buildings. We use a very less water in a green building. It encourages solid waste segregation. So, all the definitions or all the features that I have just told you about the green buildings, this is how we define our ratings, and this is how we address the coming buildings of the future. But, we talk about water, we talk about energy, we talk about a lot of other aspects.
Madam,
how do we know? Hello.
Please full screen करिए.
Oh, sure. So we will talk about different aspects. Sometimes we have heard from buildings. They say, I have built a very good design. My building has got very good solar. I have mounted very good solar plants or the rainwater harvesting plants in my building. I have heard a lot of projects that do small bit of the work, but they are not able to quantify it. They are not able to say that, how much saving have I done in my project. So this is the basic essence on which our GRIHA rating has been developed. Unless you are able to measure what savings you are doing in a building, you will never be able to manage it. So this is the basic line that we are saying, that what gets measured gets managed. The things that you are able to measure are the things that you are going to manage in a project. So we have developed the ratings based on this philosophy. Now, coming to the main definition of GRIHA, GRIHA, as I've told you, is Green Ratings for Integrated Habitat Assessment. It is basically a tool to facilitate design, construction, operation of a building, and in turn measures the greenness of a project. So how much is your building green is basically a measure of all these aspects. So as I've already told you, it's a joint venture of Ministry of New and Renewable and TERI, and this is our logo about GRIHA. When we start constructing any building, we have to take a lot of permissions, and we all know that we have to go and have clearances for pollution, for site clearances. We'll have to have basic clearances how we are, be it water, energy, or other aspects. So the attempt of GRIHA was not to create anything of its own, but to consolidate all the existing rules and regulations and put it in one place and ensure that all these regulations are being followed. So National Building Code is the main handbook that is being followed for constructing buildings. You all may be aware that we have a code for energy that is called Energy Conservation Building Code, that is very popularly known as ECBC. Then Ministry of New and Renewable have very specific guidelines for how to use renewable energy. Then we have BIS standards for how the products and raw materials are to be used. So it is also, the GRIHA is also in sync with the national objectives of Action Plan on Climate Change. So today we are basically going to talk about the 9 sections that I'm going to show you now. We are going to talk about a sustainable site. How do you choose a site? What are the features that you should take care when we talk about a proper site planning? Construction management practices hold a very key role in how we are constructing green. We are going to talk about energy, and this also takes care of the renewable section. Then we are going to talk about occupant comfort and well-being. We are going to talk about water, sustainable building materials. How do you manage waste? It is pre-construction and after construction. The socioeconomic strategies and performance monitoring and validation. So this is in a nutshell each section, what weightage it has in our rating. So this is done based on a survey. So based on a survey, we realized that energy holds the highest importance. So when we rate any project, energy will have the maximum weightage, that is 20%. Water has the next highest, that is 17%. Then we have sustainable materials, occupant comfort, and the other percentages as you see on the screen. This is how we rate our projects. There are certain mandatory criteria that you have to meet in a rating. Once you clear those mandatory criteria, I'm telling this again and again because unless you meet those mandatory criteria, even if you have a score of 86 points, it is not valid because for us in a rating, you have to go through that mandatory clauses. Even if your single mandatory clause is not met, it doesn't matter how much score do you achieve. So once you meet those mandatory criteria, the scores, how you achieve the stars is there in front of you. So if you have a score of 25 to 40 points, you achieve a 1 star. And if you have a score, a green building score of more than 86 points, then you get a 5 star. So there are 100 points. And there are 4 points, there are special points that we have kept for innovation. It is applicable to all kind of projects, high-rise, low-rise residential complexes, air conditioning projects, institutional buildings. It can be applied to all the places. It addresses the need for non-air conditioned spaces separately. Even today, a majority of the buildings that you see around are non-air conditioned spaces. So GRIHA, the way we have designed this rating, it is not promoting air conditioning projects, but the attempt is to enhance the thermal comforts in a non-air conditioned space as well. It is a way to address a lot of resources, and we believe that what we are able to sustain, is called a sustainable development. Well, when we talk about non-applicability clauses, then this is a very important aspect that I would like to explain. That there are a lot of places where, for example, the topsoil may not be available. So there are ways in which we address the topsoil preservation criterias. So the places, if we get the soil test done, and if you're able to prove this, that the soil is not fertile in a particular place, then we are able to say that you are exempted of that clause. So how you are going to do that? If there are no rainwater recharging, if the ground level water is already very high, then we don't recommend that you should go for aquifers, or where water saving is not required. So it is, we tweak the rating in such a way that it is applicable for all the regional applicabilities. Now you can see in this particular site that there are no trees available. So GRIHA does not insist on that you have to have site, you have to preserve the trees on site. If there are no trees available, we clearly exempt you from that clause. Now there is a lot of myth in the market that green buildings, they cost more, but the whole idea is that, do they really cost more? So this is a very, very interesting slide, and this is my favorite as well. That we always have been complaining that if we are going in for a green building or a sustainable buildings, they will cost more. So let us today observe, where do the buildings cost more. So basically what happens is that uh, you know we start looking at sustainable parameters or green parameters at very later stages of a building. So we say in GRIHA that if you are able to dovetail, or if you are able to incorporate the green features in the design aspect itself, we talk about a climate responsive architecture. If you are able to have an efficient building envelope, daylight harvesting is integrated in your project, and there is proper integration of natural resources for cooling and heating in a building design. So these, if you're able to do these kind of measures in very early stages of the building, it's the least cost impact that it has on a building. Rather, we have seen that the cost of a building may even go lower than your base cost if these are incorporated at the right time, and with proper planning. So you are able to reduce the cost. So now, in most of the projects, what we feel is that uh, they are they understand these features probably very later in the project, and sometimes what happens is, I was in a rush and I did not understand about the design aspects. So I still say that I want to construct a green building. Okay, so even now it is not too late. So what I do is that, if I have not been able to do justice at the design stage, I recommend that you should go for energy efficient equipments. In order to enhance the efficiency levels of your building. So then, the second stage is that we should have energy efficient equipments like lights, fans, air conditioners, efficient building operation maintenance through BMS and smart meters. So this is the second stage where you are able to enhance the sustainable or the energy efficient aspect of your building by having the star rated appliances in your building, which have a value, and which are able to say that this is the savings that are achievable if in long term this is the monetary benefits that I can achieve. So this is the second stage. Now I did not do a good design. I did not install very good equipments. The last option that I'm left with is only and only that I integrate renewable. So there are a lot of projects that they don't do proper planning, and all of a sudden there is a mandate that has been given to the project that no, you have to achieve green. So what they do is that in a rush, they just start installing renewable systems on their projects. So now we all know that renewable systems are not very cheap in cost. There is a cost attached to it, and the payback periods are very high. So if you are able to do a very good design, the payback periods are less than two years. If you are looking at equipments, if you invest in good equipments, then the payback periods are less than 5 years. We all know that the building structures, they stand for more than 50, 60 years or even 100 years in our country. So if you're looking at payback periods of less than 5 years, it is not a very big, the time duration. But when you talk about renewable energies, the payback periods are very, very high. It can be more than 10, 15 years. So it is always advisable that, GRIHA, emphasizes on this fact that, you should start thinking green at very early stages of the project. So this helps you to not only reduce cost, but also to ensure that, right kind of interventions are achieved at the right time. So any doubts on this slide, or can I move ahead? I would like to give it a pause here and understand if you're able to understand my presentations, if there are any questions till now. Okay, my presentations will be shared definitely. Okay, so I see the questions, so I am going to move ahead. So moving ahead, similarly, when we talk about water, there is a lot of savings that can be achieved if I'm able to optimize the demand, if I'm able to design my systems in such a way that, the water demand is very less on my project side, then that's the least cost impact intervention that I can think of. But if I have not been able to design a good water system, then the second step is that I go in for efficient water systems at my site, which is like low flow fixtures. We all know that these days a lot of the systems that are available are quite energy efficient. And even if I skip doing that, I think the highest cost impact systems then are installed in a building. These are like recycled water in water harvesting systems. This not only costs a lot of money, but a lot of effort goes into designing these systems. So it is extremely important that we start looking at all these interventions at the right time. Now, these are some of very beautiful examples that I would like to share, that how by optimizing, the demand, or by proper designing, they have been able to reduce their dependence on artificial systems. As you can see, this is a day-lit laboratory in IIT Kanpur. As you can see, there are proper daylight from the windows, and as you can properly see that there is no installation either on the site. They may be, but they're not using any artificial lights during the day. So this is a perfect example to show that how through a good design you are able to reduce your dependency on artificial systems. This is another example. This is a day-lit office. It's in Pune, and it is called Suzlon One Earth. These are office spaces, and as you can see, by having proper shading devices, they are able to have the glare factor has been reduced, and they are able to have proper light at all the desks. We have always thought that IT buildings, they consume very heavy. They have to have a lot of requirements of energy, air conditioning, and their demands are very high. So now this is a very beautiful example of Infosys Hyderabad building. It's a day-lit office building, and as you can see that there is use of fans and sensors in this building. So what does a rating depend upon? So we have seen that the building has its entire life cycle. So if we are able to adopt the features at the right time. Now when we talk about the pre-construction stages, This basically addresses the conditions within the site and outside the site. So if we are able to address these are called the pre-construction stages. We need to have proper planning and construction stages, which means we address issues like resource conservation, reduction in resource demand, reduce optimization of resources, resource recovery, reuse, and provision of occupant health and comfort. These are the parameters that we look at when we say that we are building, planning, and construction stages have been addressed. Building operations, they become extremely important in a green building. They address issues like operations of a building. Most of the examples we have seen that, even if they are green buildings, they don't operate the buildings the way they should be. No matter what kind of product you make, everything needs maintenance. We all know. Even if you look at your two-wheeler or a four-wheeler, we all know that we give those vehicles for service, and that is how you're able to enhance the life, and this is how you improve the efficiencies of your vehicles. Similarly, even the buildings, they demand maintenance. So most of the buildings, they think that they will run on their own, they don't need any maintenance, and this is how we are going to just keep using the buildings. So this is now not how it works. We need to have proper operation and maintenance plans for buildings. Building responsive to global and local environment, this is extremely crucial because we are responsible to what we are going to give to the environment. So it addresses issues that affect global as well as the local environment. So these are all the processes that are there when you start registering a project with GRIHA. To begin with, we have an online registration form. Once the submission of the project details and the payments have been done, the first and the foremost step that we do is to conduct an orientation workshop. Now, you may all ask that why is a workshop required at such an early stage? Now, we all know that, in order to have a project, usually have more than one teams that work on it. We have the architects, we have the electrical people, we have, the construction management companies, we have, other MEP consultants, there are a lot of people who are working in silos. So when we do the orientation workshop, we ensure that all the people who are going to be associated during the life of the project, they are made to sit together. They are able to, come together and understand what are the requirements of GRIHA, and they are able to align themselves to the main requirements. It cannot happen that, we don't design an air conditioning system keeping in mind the requirements of the building. You cannot over-design a project. If we over-design the project, the entire intent of doing a green building fails. So, we all have to work together in a project. This is what is called a proper planning. So once an orientation workshop is done, the first requirement that we ask for is submission of compliance forms. So these are basically the submissions that you do to the government in forms of, if a site is good for construction, and various submissions that have been used to the government to ensure that that particular site is fit for construction. So then beyond that, the first thing that we do is, this is the first stage. This is called the design stage. So we have taken care of the design aspects in this section. Once the compliances, once this workshop is done, we ensure that we as GRIHA, so to tell you that all the site visits that we do it on our own, and GRIHA is the only rating system that encourages of checking all the things on the site. So we ensure that we go on the site, we do the due diligence site visits. We do a minimum of 3 site visits during the life of the project. The last visit can be conducted after the commissioning of the systems on the site. Assessment of compliances is done. If we feel that there are certain things that are missing on the site, we report it to the client, we report it to the consultant, and we ensure that compliances are met. So once the compliances are met, the first documentation happens. The documentation says that that's the first review of GRIHA. GRIHA Council presents the comments on the completion of the compliances. As I had informed you initially, that there are certain mandatory clauses that you have to meet to go ahead with your green building rating systems. So if there are any shortcomings in those compliances, we come and report that to you, and we tell you that you cannot move ahead unless you complete these mandatory compliances. After the first review is done, then submission is done by the GRIHA Council. The second review is done by the third party. So GRIHA ensures that we maintain complete transparency of the project. Then we give these reviews to the third party. They see these comments independently, they review them, and then they resubmit for clarification. So we have taken care of here that all the processes that are being constructed or whatever goes into the construction phase are compliant. And because there are certain things that can be checked only during the construction phase, what materials are getting used, how the sites are getting managed. So this becomes the extremely crucial part of the green rating systems. So we ensure that GRIHA teams are there to monitor these buildings during construction. So after the first evaluation is done, we ensure that the operation part of it is also taken care of. After the second evaluation is done, GRIHA Council it proposes the final score. We tell you that this is your final score. So we have taken care of the operation side. We ensure that during this site visit, we are able to tell you, or we are able to check what appliances are going into the building and if they are compliant to the GRIHA requirements. After you have completed the building, usually GRIHA gives you a provisional rating. Now, this is a very, very important aspect which I would like to share here, that our rating system, we do not give something based on the design aspect of your project. So this is a place where the commitments are just made. So we are just giving you a rating saying that you will be able to achieve this in future. So this is a place where we are trying to tell you that you have got a provisional rating, so you have still not got the final rating. So this is the place which is the maintenance part becomes a very crucial aspect. So once the building is operational for a period of 1 year, and if you are able to give an audited statement claiming that whatever commitments you had made during the design stage, you are able to fulfill them, then we give you the final rating. So this is the entire process of how we rate a project. So this is how we conclude a project. GRIHA, as I had informed you initially, we rate all kinds of spaces, hotels, retail spaces, institutional buildings, all of them. For built-up areas of less than 2,500 square meters, we have the GRIHA main ratings. The built-up areas of more than 2,500 square meters is GRIHA rating. For built-up areas less than 2,500 square meters, we have the SWGRIHA. So these are usually very small buildings that we look at. These are called simple, versatile, affordable ratings. Then we have ratings for very large campuses. These are usually, very large universities or campuses that are coming up. Then these are basically the master plan rating. So master plan rating basically takes care of how the larger design of that site will be done, so that you are able to properly plan that site. So basically, even if the project is going to be made in phases, we ensure that whatever major installations are to be done, be it the sewage treatment plants or be it the rainwater harvesting plants, they have to be planned well, so that when you are constructing these projects in phases, you don't miss out on the main installations. Very recently, we have designed a new category, which is GRIHA for affordable housing. We have very innovative rating for the existing building categories, which cater to projects of more than 2,500 square meters, which is called GRIHA for existing buildings. We have very, very innovative program for school children, and this is called GRIHA for day schools, in which we involve the school children to rate their own campuses. And we also, in a way, teach them how to calculate emissions and various aspects of green on their project. So these are all the clearances that are usually required. These are benefits of adopting GRIHA. So you get a fast track clearance. We all know that for large projects, we have to go in for the EIA clearances. So it helps you to faster that process and get a faster clearance for if you are GRIHA registered. These are all the incentives. I will not go into the details of the incentives. They are in front of you. So a lot of state, because buildings is a state subject, a lot of incentives have been announced by the state government. Somewhere there is a 15% FAR and there are 5% FAR for GRIHA rating projects in Rajasthan, Noida, Punjab. Government of Delhi has adopted it. Government of Assam has adopted it. Even now Maharashtra has adopted GRIHA. So a lot of state governments have already aligned themselves to our GRIHA ratings. Now I will quickly go into the sustainable site planning and the criteria that I had just mentioned. So there are 6 sections that I had told you initially. So I will go through them one by one. The aspects that I will cover in site planning are what kind of site selection aspects you should take care when you are talking about sustainable site planning. How do you preserve, protect landscape during construction? What are the soil conservation techniques? What design to include in existing features? Reduction of hard paving on the site, and utilization of plant utilities efficiently and optimize on-site circulation efficiency. So, what is it that you find is missing in this site, or what do you think is something that is not correct on this site? Okay, so I don't see a lot of people are answering, but I will definitely like to quickly tell you that this is a very typical example that we see on a site, that you see that this is a area which has been demarcated for the project, and what they have done is that they have constructed just 40% of the project here, but they have cleared the entire land here. As you can see, they have made the entire land barren here. So this is not a very good sustainable practice. So site protection, site selection, preserving and protecting landscape during construction, soil conservation, designed to include the existing site features are some typical things that we look at when we go for our site visits. And we also encourage that you shouldn't do these kind of things when you are constructing projects. So do we really know how much time does it require for a topsoil to regenerate? Any answers on that? My question is that if once your topsoil goes away, how much time does it take for a topsoil to come back? 10 years. Okay, any other guesses? 10:56 a.m. Somebody said more than 50 years, 1 year. Okay, Ronak Shah is saying okay. So somebody's guessed it right that most of the topsoil, once it is gone, it takes roughly 100 years and sometimes even 500 years for the topsoil to come back. So when we talk about sustainable site practices, the one practice that we usually encourage is that we should preserve the topsoil. So whenever you are, excavating the topsoil, we ensure that that's preserved and it's been used later, for doing all kinds of landscaping on the site. So this is the first and the foremost step that we encourage the projects to do. How do you preserve? We have seen that this is how the topsoil gets run away if you are not having good practices. So these are some of the methods in which you can preserve the topsoil. You should use natural drains on site for soil erosion control. There can be sedimentation tanks that can be installed where the runoffs are not there. Stacking mulching is another way where you can grow some grass on the topsoil, which is already, we have removed it from a place. So these are the processes how we preserve the topsoil. How do you respond to microclimate? This is a very architectural way of looking at it. We should design a project in such a way that the longer facade of the building should be oriented along the north-south, which means that the longer side should be on north and south to avail maximum daylight and minimum solar radiations. This is a very good diagram which tells you how the sun paths they follow and how if a building is properly oriented, it can help you reduce the glare factors and the heat factors in a building, and the time of the year where you need maximum heat is the time where if the building is designed well, you are able to get maximum solar through those windows. So this is how you design a building, and it helps you to respond to microclimate of that feature of that land. So these are very typical orientation diagrams which help you to understand how do you design a good site. So this is another example that how do you shade the windows where the glare comes in from. So this is another way of designing a good project. So I will not go into the details of this project, but this is a very beautiful project that has been constructed in Panchkula. This is a net zero building. So it has been designed in such a way that a lot of features were incorporated in the design aspect itself, and the way it has been designed, it requires minimal help from the grid, for its daily operations. So these are some pictures of that project, which shows how they have been able to lit their common areas through natural lights. This is another example of IIT Kanpur, in which you can see that they have been able to reduce a microclimate of a place or reduce the glare factors in their project by preserving the natural trees that were there on the site. So they are constructed only in those areas where the construction was required. These are all the trees that were already existing, and they have preserved them. So this was a natural existing water body, and very beautifully they have ensured that they were able to maintain this on the site. So this is a design to respond to an existing water body. Now, this is a very simple technology, or you can say an aspect which we have done in our engineering, that is called the urban heat island effect. So on your left, you see a rural area, and on your right, you see a typical city area. We see that when there is the glare of the sun, how heat absorption rates are different. So we all know when it is a hard paved area, the heat absorption and retention is greater than when it is a grass paved area. So on your left there is on your left there is tree plantation, transpiration is happening, and on your left, because it's all concrete, there is very less transpiration, and of course there will be no transpiration because of concrete areas. So there is no water in terms of evaporation that is happening. So what happens is that when you are in a rural area, you automatically feel, even if the temperatures are same in a city, but you travel through a green area, you definitely feel that the temperature has lowered. So a concrete jungle or places where we have commercial projects, there is a 3 to 10% increase in temperature because of the kind of construction that we are doing. So what are the various ways in which we can reduce this? As per what we are recommending, is that as per national rating system, the paved area surfaces should not exceed more than 25% of the site area. So this is a very typical example that you can use to ensure that there is more green patches in your area, and this is very easily doable. It doesn't cost too much. Landscape has been designed to maximize the green areas. This is another way of doing it, and it also maintains the aesthetics of the project. Preservation and protection of mature trees is something that we have always encouraged. So in a typical construction site, what we have seen is that we try to stack a lot of raw material under the trees. So this is something that we don't encourage. Trees is something that is very important aspect in a green building. So preservation and proper site planning has to be done. This is another example of how we are stocking material under the tree. So there are very cost-effective ways which we can. These pictures, they depict how the trees can be preserved on the site. So this is a usual site where we see a lot of dust is getting, there on in the air, and construction site are the major producers of air pollution. So this is not a very good example, or this is not a very good example to say that we should encourage these kind of practices. Air pollution, we all know, is the fifth leading cause of deaths in the country, and the number of deaths that get reported are in the range of more than 5 lakhs every year. So this is and a construction site typically emits a lot of pollution, and nowadays you may have seen that a lot of these kind of barricading that is being done. This has been mandated by the government. It is essential and it's mandatory to barricade the sites from all the sites. This is what are of good examples. This is another good example where you have to cover the dusty construction materials to reduce the air pollution. Now, the generator side, we usually use these kind of generators, DG sets, on our sites. The exhaust heights of these sets have to be such that it doesn't cause a lot of pollution. Sprinkling of water, this is another way of reducing. So this is a very good example where they are sprinkling water on the site to ensure that if there are winds or if there's air, then there is no pollution that's spread into the air. Wheel washing, this is another technique. We ensure that once the trucks are going out of your site, then the wheels get washed. So what you do is just maintain some water at one particular exit gate, and once the truck passes through that site, its wheels get automatically washed. This is another example to show how the materials have been stacked, and this is where is the site. I mean, this is how we ensure that materials should be managed. If we are able to manage the proper segregation, then we are able to also reduce the kind of damages or the losses that we get on the site. We request for a construction site plan. This typically tells you where are we storing, which are the storing areas, which are the stacking areas, how are the boundary walls that are getting managed, the color codings should be there, and how are we going to manage the traffic. So all these details should be managed on or should be marked on the construction site plan, and this is what we verify when we go on the site. Now we come to our next section, that is energy efficiency and optimization. Over here, we talk about enhanced outdoor lighting systems. We talk about optimizing building design, overall energy performance of the building, renewable energy integration, solar hot water systems. Outdoor lighting systems, the lamp efficacy controls, design optimization. Over here, we talk about WWR, shading devices, effective daylight, artificial light. I'm sure you all are aware about these terminologies. Efficient systems, we have to be ECBC compliant, and there are EPI benchmarks that I will just tell you. And this is called energy. This is how you reduce the demand. And by using solar, you are able to offset these demands by RE. And we typically talk about solar, wind, biogas, and geothermal processes. So this is demand management and this is supply management. So the design aspects, when we talk about the design aspects, we maximize the living areas should be daylit. So wherever there are living areas, it should have maximum daylight. There are certain specifications for window to wall ratios, and artificial lighting has to be maintained as per NBC level 2005. For energy, we talk about ECBC and renewable energy utilization. Now, this is a very typical example which naturally tells us that when we observe glare, this is how we are integrating the natural phenomena to our buildings now. So I will show you some pictures in which you will be able to see that how we naturally react to, when we get glare, right? So this is definitely a very good example that you start putting your hand on your eyes so that you can cut out the glare part of it. Another example is that you reduce your eye size, right? You are able to cut the glare by reducing your eye size. So this man that you see in the picture is able to cut out his glare by reducing his eye size. So what happens in our typical glass buildings? Why we should not have a lot of glass in the buildings? So I will show you a few pictures. Now this is a glass building and there is a desk that has been purposely put to ensure that we are able to set this example, and you can see that there's a lot of glare coming on this table, and it is extremely difficult for somebody sitting here to sit and work. In spite of having the entire window as glass, still the person who will sit here will not be able to work in a proper environment. You are not even able to see your phone properly because of the amount of light that is coming in your building. This is another bad example that shows that there are a lot of windows in this building, but still there are artificial lights that are switched on. They have used blinds and they are using artificial lights. This is another bad example. So we have talked about having maximum openings on north and south, and maximum living areas should be daylit. So these are some of the analysis to show that how do you achieve daylighting. So the first solution is to reduce the floor plate by half, but providing openings on both the faces of the space. And definitely, these are certain things that can be achieved at the design stage itself. Only certain areas close to the window they receive access light, while the rest of the buildings we feel in this particular project, as you can see, that only these are the areas that are receiving maximum light, but all these areas are not having proper lighting. So this is not a very good example. So if we are able to use proper methodology during planning, and there are softwares that are available which help you to understand what kind of lighting integrations have to be done, then you are able to reduce the demand for artificial lighting. So this is the work that we have to do at the design stage itself. So this is the first picture in which we talk about window to wall ratio. This is 40% or I think more than 40% window to wall ratio. It helps you to have a lot of daylight into the building, and it definitely does not bring in glare. But the second building is 100% glass. It not only brings in glare, but you will be bound to have blinds and other aspects to ensure that you are able to sit in this building. So the proportion of WWR is sufficient for this project, and this is access window to wall ratio. So what we say in GRIHA and what is recommended also in other the manuals that the government has listed is that WWR should not exceed 60% of the gross wall area. So this is an aspect we should take care when we are designing a building. So these are the calculations to show, and this is a formula that is to be used while calculating the daylight of any project, which is 2h into the width into 2 meters. For introducing the lighting levels in each spaces, proposed indoor lighting, we have to use the lighting and ventilation of NBC 2007. We have to follow these guidelines. So these are the recommended lighting levels as per NBC for commercial buildings, office spaces, conference rooms, drawing offices, the general board rooms. How are going to design? What are the various illuminance levels or lux levels that are required for each room? So this is how we design. Enhance outdoor lighting systems, lighting system efficiencies. Luminous efficacy of 100% of lamps used in outdoor lighting should be met, corresponding the lamp luminous efficacy as mentioned in table 6.1. So these are the efficacy levels of various kind of lamps that are being used for outdoor light. Automatic controls for 100% outdoor light should be used. So this is a mandatory criteria of GRIHA. So now what is luminous efficacy for all those who are new to these terms? It is a measure of how well a light source produces a visible light. So if you give a typical example, if we are using a 100-watt lamp, it produces 1000 lumens, which means that the luminous efficacy of that is 100 lumens per watt. So lumen is the SI unit of luminous flux, which refers to the total amount of visible light emitted by a source. So these are the controls that are to be required in a project. To give you very briefly about what is ECBC. ECBC is basically is referred to as Energy Conservation Building Code, and the purpose of having this code is to provide minimum requirements for energy efficient design and construction of a building. An ECBC building is typically talking only about the energy aspect. So in ECBC, we talk about envelope, how do you design an HVAC system, how do you design your lighting, how do you design your electrical power systems, and hot water and pumping. ECBC compliant buildings are usually 40 to 60% more efficient than a conventional BAU buildings. If we are following ECBC, we are annually, if all the buildings start following ECBC from now, we will be able to save nearly 1.7 billion kilowatt hour of savings. Energy Performance Index is one of the benchmarks that has been used to assess the energy performance of your building. It basically says that by definition, energy performance index, it means the total energy that is consumed over the year. It is, how do you calculate it? It is total energy consumption of that particular building upon the total built up area of that project. So for different buildings and for different typologies, there are different EPI values. So the unit for EPI is kilowatt hour per meter square per year. We have divided it into 5-day functions and 7 days function on 24-hour operations and daytime occupancy projects. This is how the classification is done, and it is also based on which climatic zone is this building coming from. For commercial buildings, for a moderate climatic zone, the EPI value is 120. For a 24-hour occupancy, the EPI value, minimum EPI values that you have to achieve is 350. For a composite and warm and humid or dry type of climate, the EPI values is 140. For a 24-hour occupancy, it's 450. For residential buildings, if it is composite, warm and humid, and hot and dry, if it is in these zones, then the EPI values is 100. For a moderate, it's in 85. Rated capacity of the proposed renewable energy system should be equal or more than 1% of the artificial lighting. So whatever artificial lighting, interior or exterior, you are using, 1% of it should be met by renewable energy systems. This is what a GRIHA rating system says. And space conditioning connected or its equivalent in its building. So if we talk about the total energy that you're consuming for artificial lighting and space air conditioning, 1% of it has to be met through RE. So this is how we have seen in a lot of projects how RE projects are getting installed. These are various technologies that are being used to install systems, RE systems on a project. An RE project, this is an Indira Paryavaran Bhavan, which is in New Delhi. So as you can see in the pictures that it is providing shaded roofs. Solar PV, they have used it on elevations. So this is also doing dual purpose. Not only is it providing energy, but it is also providing shading to the atriums. So this is how we have shown you some examples of some very important projects. Resource management. Now, when we talk about resource management, over here we are going to discuss water management and waste management, how we are going to reduce the landscape requirement, reduction of landscape water use, efficient water use during construction, wastewater treatment, water cycle reuse. In waste, we are going to talk about reduction in waste during construction, efficient waste segregation methodologies, storage and disposal of waste, and resource recovery from waste. Now, the world statistics says that total world water, just 2.5% is fresh water, and the rest is all salty water. And out of it, the fresh water that you're getting, you get 0.3% from freshwater lakes and rivers, 30% is groundwater, and 70% you get from snow and ice covers. So typically, this is what is the site on most of the fresh water that is coming or that is available in our country. So this is what happens when we don't plan well. These kind of disasters are bound to happen. Water resources are extremely polluted, as you have seen in the previous examples. There are policy initiatives that have been taken, policy documents on natural resources, and how policy statements have been there, that how are they going to conserve water. So these are all the policies that have been listed that shows that how proper regulations are there in the Indian Penal Code, which tells you how the water quality managements have to be done. So there are specific CPCB guidelines which says that we are responsible for implementation of legislation relating to prevention and control of environmental pollution. So unless you have the CPCB clearance, you cannot have a site good for construction. You have to maintain the CPCB norms for a good construction site. Optimizing the water demand side water management, and we did talk about the supply side management. How are we managing water during construction? What is the building water requirement, and what is the water that we will use for landscape water requirements? On the supply side, we talk about water reuse and recycling, and we talk about rainwater harvesting systems. Demand side management, we should avoid free flowing water for curing. So this is the best way of reducing water. We know that we need a lot of water for curing. So this is how we can cure, by keeping gunny bags and ensuring that a lot of water doesn't just keep flowing. So by using water efficient fixtures, reducing the building water requirements, the water closet conventional flow rate is 9 or more LPF, and urinals conventional flow is 9 LPF, and then there are waterless urinals. So low flow water closets will have 6 to 3 LPF. The urinals will have low flow of 4 LPF, and these are very typical, very good examples to show how we can reduce. Studies indicate that sensor faucets save more than 70% of water if we are installed properly. So how do you calculate the total consumption of water in as per GRIHA? Total consumption is basically based on the number of total occupants, the total flow rate of each type of fixtures, and number of uses of each type. That is number of fixes. So number of uses in case of water closet and urinals is equal to the number of uses per person, and number of uses in case of faucets is equal to the number of duration of each use and number of use per person. So these are the various values of fixtures, water closets, kitchen faucets, water faucets, waterless urinals, and lavatory faucets. I won't go into the detail, but I'll share these presentations with you. This is how you reduce the landscape water requirements. So we don't encourage a lot of lawn spaces, because we all know that lawns, the grass requires a lot of water to keep it green the way it is. So there are a lot of other ways in which we can propose to be green. We can have a lot of native shrubs, trees, lawn areas can be reduced, and still we can have proper greenery maintained in our campuses. Supply side management. So over here we talk about reuse of water, recycling of water, and rainwater harvesting systems. Uh, Water reuse and recycle, why is important? Because urban areas are facing big water issues. We will not have water in the coming times. Probable reason is overdrawing of groundwater. We are not replenishing the aquifers. Water is undercharged. So we know that the amount of rainfall that we receive now is much less what we used to receive. So now the dependence on water will have to be reduced through buildings. So these are typical rainwater harvesting plants or systems that get installed in a project. So these are aquifers for secondary application has been used, and storage of rainwater in the wells. So these are some examples where we have installed aquifers. Now we talk about wastewater. So there is grey water and there is black water. We all know rainwater is that water which you use in your bathroom sinks, showers, tubs, etc. And black water is basically used to describe wastewater containing your urine, your flush water from flush toilets. So for black water, we have municipal sewage lines, and for grey water, we have customized, cost-effective solutions. There are two major advantages of treating grey water. Grey water typically can save up to 30 to 40% of consumption. The treated water can be used. So whatever grey water that we just saw can be used, reused for toilet flushing, irrigation, cooling of towers, usually, and for fire hydrants, car washing, cleaning systems, etc. Reduce the load on municipal sewage lines and treatment systems. These are two major advantages that we have. Breakup of water requirements. So this is per liter requirement per day that we have on water. Grey water accounts for nearly, as you can see, that 2/3 of the total water consumption. So this is how we can treat water. I won't go into a lot of details of how we are treating water. So there are biological and there are chemical ways of treating this water. So these are typical examples to show how we are treating grey water. So there are certain kind of plants that are available that help you to, and they're very cost effective ways of doing it. Grey water, there are tall towers that are green and they help you to maintain that aspects, and they're able to treat that water naturally. This is another system in which the systems have been installed to treat grey water. This is how they're using this water to water their plants. Solid waste management. We all know that the amount of waste that we see around, it's becoming a very big issue. So we are generating nearly 90% of waste are being put into landfill areas and require nearly 1,200 hectares of land every year. You know, the way we are producing waste with an average depth of 3 meters. Per capita waste generation is to the order of 0.5 kgs per day in metros. It is very important that we reduce construction waste, design stage planning to minimize the generation of construction waste. Design should be checked to see that there is no over specification materials. So sometimes we have seen on sites that there are materials that are just stacked on the site and which are over designed and they are not required, sometimes on the site. So the extra materials, they become waste on the site. The design should be sized according to the size of the material available. So we have to design in such a way that we are planning it better, and we should reduce the amount of waste that is getting generated. Should be stored in proper waterproof sheds. We have seen that a lot of material, they just get washed away the amount of material that we are stacking is not sufficient. Post occupancy, we all are aware the kind of bins that are to be used, the different color coding that are available, how paper will be disposed, how are we going to dispose of plastic, and what are we going to do with the organic waste. So all these features are already there. So these are various techniques that are available in which we can reuse waste. We know that manure creation is extremely useful, and how we can decompose it to make manure. So these are very typical examples, very cost effective ways of converting organic waste into manure. Then there are chemical ways of doing it. So these are some examples that are available, technologies that are available in TERI. So this is technology that helps you to convert your waste to manure, organic waste converters. Uh, is there any building material which is sustainable? Yes, there are materials which are sustainable, and we are talking about maintaining those. And if there is a material X, we know that how that material travels, extraction, processing, packaging, and then shipping, construction, installation, operation, and maintenance, recycling, and reuse. These are the three phases how a material travels. How do we select a building material? It should be pollution free, waste reduction, recyclable, embodied energy reduction, reduction in construction waste, energy efficient, water treatment conservation should be done, should be non toxic, reusable, and recyclable. We should use BIS standards for materials. Reduction in embodied energy should be reduced. So these are the criteria that we address in sustainable building materials. Use of low environment impact materials in building interiors. There are technologies available for materials. There are technologies for precast slabs, hollow floor slabs, precast reinforced bricks, microconcrete roofing, etc. For roofing, we should use precast non-load bearing concrete blocks, ACC blocks, CLC blocks, mud walling systems, compressed earth blocks. All the systems that you see are various kind of materials that you should use which use low energy. Hollow concrete blocks, these are some of the typical examples to show how are they being getting installed. Hollow concrete blocks. This is a typical building that's been made by bricks. This is how is a typical way of doing how the bricks are being used in a building, and this is a picture too. So the amount of brick and the amount of cement that's been used, there's a potential saving that's possible the way we are constructing it. This is the base case that's called the English trap, and this is the rat trap bond, and this is the percentage saving that can be achieved by just making some changes in the way you're using bricks. So these are some typical examples of how the embodied energies are getting calculated for concrete, steel, and bricks. Recommended sources for embodied energies, there's no specific study there's no government document that says that, but there are embodied assessment studies that have been done by some researchers, and these are the places where you can find them. I'll share these details with you. So these are some of the examples that show that how recyclable materials was used in buildings and how it has enhanced it is not only cost effective but is also recyclable. We at GRIHA, we also maintain a product catalog and we maintain all the materials. So there was a lot of discussion around that. There are a lot of materials that are available in the market, but we don't know how cost effective are these materials. We don't know what is energy efficiency levels, what is the sustainable aspects of these buildings. So we started maintaining a product catalog within GRIHA, which typically tells you what are the parameters that you should look at when you are searching for a particular product, be it your walling material, be your paints, be your water faucets, or be it your glass. All these building materials have been listed in our product catalog. You can find the access to this on our website. I will quickly come to the socioeconomic strategies because we have very less time now. We in GRIHA are the only rating systems that talk about labor, safety, and sanitation. We talk about designing for universal accessibility and dedicated facilities for service staff, increase of environmental awareness programs. So this is a usual site picture in which you can see that the laborers are not wearing any safety gears or even proper shoes. So the amount of mishaps that happen in a building are much more. The kind of sanitation facilities, we don't care how how the laborers are living on the site. So this is a typical site that the lady is washing clothes in the same water, and probably she's using the same water for drinking. These are the kind of toilet facilities that are being provided to the labor. So you can see the kids that are playing around the materials, and this is extremely, extremely harmful and can be very dangerous. So this is typically a place where a person is using the same water for washing as well as bathing, and these are the kind of toilets that are being provided to them. So these are some of the good examples to show you what kind of good practices one should maintain. You can see that there are people with proper safety gears, helmets, and shoes. The water that's been used for drinking purpose is being covered and is being used for a proper source. So as you can see, proper barricading is being done, and it's to ensure that people should not pass this site when they are using. So all these people are using safety gears. The big sites you can see in these pictures as well, everyone is properly using safety gears. So these are some of the very, very good examples where they have provided proper drinking water facilities to the labor. They are also providing proper dining facilities where they can all have common lunches and dinners. These are very good examples to show how proper toilet facilities and room facilities were provided to the people who are going to live on the sites, and proper houses were provided to the labor. So these are all good examples to show that we have to have proper management systems for people working on the sites. So in a lot of sites, we see that we don't provide enough of facilities for disabled. So GRIHA encourages that we should have toilet facilities for disabled people as well. Performance monitoring and validation becomes one of the most crucial aspects of GRIHA. Smart metering and monitoring, operation and maintenance protocols, performance assessment for final rating, and innovation criteria. We all know that monitoring is very important when it comes to typically managing your project. Smart metering and aligning yourselves to the main systems and ensuring that you're able to regularly capture the performance of your project will help you understand the performance of your building. So Infosys is one very good example where we have seen that they have linked all the projects to one place, and whenever they feel that one project is shooting their consumption, there are triggers that are available to assess that, and they are able to monitor those triggers, and they are able to take some corrective measures for that. So there are environmental campaigns that should be conducted, and to ensure that people are aware of what kind of facilities or systems that are available in their projects. It helps to enhance their understanding on green projects. So there can be some typical examples that can be installed in project sites to show what kind of technologies are available. So I won't go into the case studies now because of the paucity of time, but I will leave these some good examples to show that how through a good design and good design principles, green principles, we have been able to do a lot of good work. So this is all from my side, and I hand it over to you, Mr. Ronak. Thank you so much.
Thank you, madam. Some question from participant. Uh, how can we improve energy efficiency of existing building?
Hello.
Madam.
Yes, sir. Yes, sir.
how can we improve the energy efficiency of existing building?
So, sir, we have an existing building rating program of the GRIHA systems. So, typically, when we talk about existing buildings, we cannot look at design features in that building. So, the main things that we look at in an existing buildings are basically how do you design your systems, or how can you relook at your systems that are installed in your building. So, we talk about energy efficient lighting, we talk about and air conditioning, we talk about your water systems and waste management systems are all the aspects that we look at when we are looking at existing building features. So basically what we do in an existing building is that before we go in for a rating, we do an energy audit of a project. So energy audit will help you capture what is the baseline of your project, what is it that your building is consuming right now, and what are the things that can be done to enhance the energy efficiency. So there are energy audits that help you to understand that these are the areas that get identified during an energy audit, and then depending on what kind of measures you want to take in a project, you are able to invest in a building. There are certain low hanging fruits in which you can do minor changes and still you are able to achieve some bit of savings, and then there are certain kind of aspects that are required in which some kind of investments are required. For example, if you don't have proper lighting in your room, or if it is an inefficient fixture, or if it is an inefficient air conditioning system, then those have to be replaced. Then it helps you to reduce the energy, it helps you to enhance the energy efficiency by replacing the systems. So it all depends on what stage you want to do what kind of measures, and there are various ways to do that.
The last question, which software that you can use for optimize the building lightning system?
So there are a lot of systems available. To name a few, there is you have to go for building simulation tools that are available. I will not know the names offhand, but I can provide you a list of all those daylighting tools that are available. So you can pose these questions to me, and I can do Ronakji, and you can pass on these answers to the participants.
Okay. Thank you, madam. On behalf of Mechanical Engineering Department ADIT, we'd like to express our sincere thanks to Shabnam Bassi madam for accepting our invitation and given an excellent lecture on
Thank you.
how to building rating by the GRIHA systems. Thank you, madam.
Thank you so much, Ronakji. Thank you.
Thank you. So, participant, please, we will meet on after 5 minutes.